This is Fundamental Problem 4 from Chapter 15. In Fundamental Problem 4, the wheels of the 1.5 megagram car generate the traction force F described by the graph. If the car starts from rest, determine its speed when t is equal to 6 seconds. They give us the graph here, which I've drawn here. And we're going to use the impulse momentum conservation law for this problem, which we have here. For the impulse, we take the integral of the net force with respect to time. Since the graph we have is F versus t, the integral is the area under the curve here. They give us the mass of the car, and the initial speed is 0, and let's say that's our car there. The only thing that's touching the car is the ground. The ground exerts a traction force, which was shown going this way. Also a normal force acting upwards, and we have a force of gravity acting downwards. Those are both in the vertical direction, so the only force that we have to worry about in the horizontal direction is the traction force. So the initial velocity is 0. The integral that we have here is the area underneath the curve. And I can find the area underneath the curve by breaking this up into a triangle and a rectangle. The height of the rectangle is 6,000 newtons, and the base from here to here is 4. So this area is 6,000 times 4. Since this is a triangle, the area is 1/2 the base times the height. The base is 2, and the height is 6,000, so that's 6,000 times 1/2 times 2, which is 6,000. So the area that I have is 6,000 plus 6,000 times 4. That's equal to the mass of 1,500 kilograms times the final velocity. And we are looking for the velocity at 6 seconds. We took the integral here from 0 to 6 when we did the area under the curve, so this will be the velocity at 6 seconds. And if we add together what we have on the left-hand side here, this gives us 30,000. If we divide it by 1,500, that gives us the velocity at 6 seconds, and that is 20 meters per second. And that is Fundamental Problem 4.